We are going to look at alternating infinite series. In this video, this will be a short one. We'll just look at what an alternating series is. In subsequent videos, you can watch them all in sequence if you want, no pun intended. We'll talk about convergence and divergence and approximations and error bounds. So first of all, what is an alternating series? And to start with, I'm going to show you something that's not an alternating series. Remember this one? This is one of the first series I usually look at when I'm teaching infinite series. Let's see if you can remember what it's called. Pause it if you need to. It is the harmonic series. It's also called a P series, right? This is the P series where P equals 1. And think about whether that converges or diverges. And this one does diverge, right? It is a divergent P series. And this is the one that has kind of a cool proof to it where that's the one where we looked at 1 plus 1/2, and then we grouped the next two terms together, 1/3 and 1/4, and said that's greater than 1/2, or greater than or equal to, I guess, although it's greater. And then we grouped the next 4 terms together and said that's also greater than or equal to 1/2, and then the next 8 terms, and then the next 16 terms. And if we kept doubling the number of terms we grouped together, we kept getting a sum that was greater than or equal to 1/2. So you have an infinite number of sums that are partial sums or groups of sums that are greater than or equal to 1/2 all added together. So it must keep going up without bound. All right, let's take this series, this divergent harmonic series, and let's add one little detail to it. Maybe this doesn't look like that much of a detail, or maybe it doesn't look like a little detail. Maybe it looks like a little bit more than a little one. But this guy right here, this -1 to the n-1 power, I call it the alternator. All right, it takes a series that was not alternating and it makes it alternating, provided that the original series had all positive terms. That's where we want to kind of start with. So in this case, this is called the alternating harmonic series. In fact, let me write that down. Alternating harmonic series. Okay, and let's take a look at what it means to be an alternating series. So first of all, let's just kind of start plugging the n values in here. So just like with the the harmonic series, it's 1 plus 1/2 plus 1/3 plus 1/4. These are still going to have those same magnitudes, but now this factor right here, this alternating factor, will multiply every other term by either -1 or +1, which makes every term switch signs. So our first term will be, when we plug 1 in, we'll get -1 to the 0 power, which is +1. So we'll just get 1. But our second term will then be negative, so we'll have -1/2. And then our third term's positive again, so +1/3, -1/4, +1/5, and so on. Okay, and that just keeps going infinitely. Again, it is an infinite series. And so I'm going to say plus ... And then we can put the general term, which again is -1 to the n-1 is how they've got it here. I guess how I've got it. And then times 1 over n. Now I will point out that n-1, it could also just be an n. If that were just n, then all the terms would kind of switch here in terms of which ones are positive and which ones are negative. And oftentimes it's written as an n+1 instead of an n-1. And that's just, it doesn't really matter. You could make it n+37 if you wanted, if you're feeling kind of funky. So here I'll put the plus ... at the end to indicate again that it is an infinite series. Again, when you write a series in this form, it's sort of an expanded form, right? And this is called the general term. When you're in expanded form, it's nice to show that because you're showing, in this case, the first 5 non-zero terms here. And then the ... here indicates that we're skipping some number of terms, who knows? And then we're showing like a general nth term, and then the ... at the end again states that this is an infinite series. It does go on forever. All right. So what is an alternating series? We got the basic idea here, but here's a good definition. An alternating series is a series in which the terms alternate between positive and negative, and it's important to understand every term must be a sign change from the previous term. They always alternate between positive and negative. If they don't, then it's not technically alternating. So if you have a series where sometimes you'll have like 2 positive terms in a row and then 2 negative terms, and then and it keeps going like that. That's not really an alternating series, but maybe there are things you could do to take a series like that and maybe turn it into a couple of alternating series. Got to get a little fancy to make that work sometimes. Anyway, how can we tell if an alternating series converges? That's going to be the next video. I'll cut this off here in a second, but let me just point out the first one we're going to look at is this series right here, the alternating harmonic series. So maybe before you get into the next video, think about this for a minute. We know the harmonic series diverges. Do you think the alternating harmonic series would also diverge, or do you think that one might converge, and why?